Today, the latest weapons, coupled with the fighting skill of the American soldier, stand ready, on the alert all over the world to defend this country, you, the American people, against aggression. This is The Big Picture, an official television report to the nation from the United States Army. Now, to show you part of the big picture, here is Sergeant Stuart Queen.
In the closing months of the Second World War, two new weapons appeared, which have since revolutionized all concepts of modern warfare: the atomic bomb and the guided missile. In order for our defense team to be able to prevent war, we know that America must have these weapons and their striking power to deter any enemy from launching an attack against us. During the past 8 years, in an unprecedented crash program, our Army has undertaken an extensive project to perfect and build guided missiles capable of carrying an atomic warhead. Now let's take a look at some of the results of these intense efforts.
During the hours of darkness, on a lonely cape projecting into the Atlantic, scientists and technicians prepare a giant missile for flight into outer space. Everything is ready.
20 seconds.
The 60-foot Army guided missile called Redstone waits poised and alone.
15 seconds.
High-speed slow-motion cameras are started.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast!
The birthplace and home of the Redstone missile is this 40,000-acre research center located near Huntsville, Alabama. Here, a crack team of the world's leading scientists have been brought together to form ABMA, the Army Ballistic Missile Agency. It is their job to design and then build ballistic missiles capable of controlled and accurate flight over vast distances. Because their projects are concerned with areas of knowledge never before explored by man, strictest security precautions are observed. In these laboratories is some of the world's most advanced equipment for scientific research. The man responsible for carrying out the ABMA mission is Major General John B. Medeiros, seated at the head of the table. Dr. Werner von Braun, the noted space expert and director of development operations at ABMA, demonstrates a model of a static test stand. The actual test stand, 16 stories high, will hold a giant missile firmly in place during full-force engine firing tests. Models are frequently used before any work is done on the real missile. Precise miniature replicas of the individual sections are made and then subjected to numerous tests and study. Design, however, is the first and basic step in any missile project. Countless engineers and draftsmen are working to solve the unprecedented problems raised by this new field. The knowledge gained from each new experiment must be skillfully interpolated at the drafting table. From the designers to the testing labs come missiles in the form of tiny scale models. In one of the aeroballistic laboratories, these models can be put into a supersonic wind tunnel and subjected to many of the conditions of actual flight. These delicate miniatures cost up to $15,000 apiece. The vacuum wind tunnel, seen in the background, will place wind velocities approaching 4,000 miles an hour on this model. Precision instruments must be used to set the model correctly. Many different shapes and designs have been and are being tested as the maximum characteristics of stability and control are sought. Minute measuring devices, located within the model itself, will measure the aerodynamic loads imposed on various surface areas. Modern electronic sensing equipment automatically transfers these loads onto IBM cards, which are later reduced to the most usable form in electronic computers. In the past, all too often an experiment like this would be the only approach used in military research. Today, a technique of multiple approach in problem solving is used, and often several different laboratories are working simultaneously on the same problem. The finest and frequently the most complicated equipment that money can buy is provided. As the missile itself is constantly being modified and improved, so are the laboratories and equipment. These long tanks are vacuum tanks, into which air will be released from high-pressure storage domes. The passage of air through the new supersonic wind tunnel seen next to the center dome will create extreme wind velocities. Here in one of the test laboratories, a scientist uses the most modern electron microscope. Although a missile in flight is an awesome, hurtling object, the size of many seagoing vessels, some of the secrets locked into its framework require research impossible to obtain with ordinary microscopes. The best optical microscopes enlarge up to 2,000 or 3,000 diameters. This electron microscope can produce photographic enlargements up to 100,000 diameters, enough to magnify a blood corpuscle to the size of a 2-foot sofa pillow. A dime thus magnified would appear more than a mile in diameter, and a human hair as large as a giant redwood tree. There would be difficulty in finding a science which does not have something to contribute to missile research. Chemists and metallurgists, for example, are just as essential as aeronautical engineers or electronics experts. Indeed, the progress of chemistry and related sciences in the development of fast-reacting yet controllable fuels was a prerequisite to the whole science of missile engineering. Spectrographic analysis is another continuous activity in missile agency laboratories. Used to analyze metallic constituents, the spectrograph can often tell the scientist not only what did happen inside his missile the last time, but also what is likely to happen next time. While research, design, laboratory testing, and expansion are taking place, the building runs continually. Here in one of the main construction shops, exterior sections are produced. During research and development, no two missiles are built exactly alike. Each one is an individual, containing changes and improvements on its predecessors. When the final missile has been perfected, its manufacture will be turned over to private industry, and the Army Ballistic Missile Agency will move on to more advanced research. In the meanwhile, all efforts are being made to perfect these missiles quickly. Unfortunately, nothing is easy in this operation. Even the welding involves special techniques needed to satisfy the exacting requirements of the missile. When this phase of construction is finished, the missile is moved to an inspection laboratory, where the newly welded seams are subjected to pressure tests and X-ray to ensure there will be no leakage. Despite many achievements, many problems remain. The greatest single problem facing the missile agency has been the procurement of the technically qualified personnel needed for this ever-expanding operation. There is a definite shortage of qualified physicists, mathematicians, and chemists. There is a crying need for engineers of all kinds, electrical, electronic, mechanical, and aeronautical, as well as other scientific and technical personnel. Already, more than 2,000 scientists and technicians have come to work at the agency and to make their homes in nearby Huntsville, Alabama. From all over the United States, specialists are finding their way to the missile project, either as visitors or as permanent employees. Huntsville's modern airport provides easy access to both the Ballistic Missile Agency and the city. Huntsville itself is a bustling, prosperous little city in the center of the rich Tennessee Valley. Because of the influx of highly educated workers, today Huntsville combines the charm and relaxed atmosphere of a quiet southern community with the intellectual curiosity and activity of a major university city. In these peaceful surroundings, the ABMA workers have found ideal living conditions. New homes have sprung up in new, modern subdivisions. These growing communities have already proven themselves to be excellent places for raising children. Huntsville schools, thanks to federal aid, are on a par with the best in the country. A gentle community, its churches represent every major faith. Thousands of new faces are to be found in Huntsville, yet there is an immediate need for additional trained personnel to help operate the expanding missile program. To recent college graduates, both male and female, who can meet the requirements at the agency, several unusually attractive employment plans are available. Here is a typical measuring room of the sort which is found at every testing range. It contains many electronic computers and delicate sensing devices. Army personnel assist the scientists in the enforcement of safety measures. These men are overcoming one scientific barrier after another, and nothing is permitted to delay their operation. In this test, a small piece of metal alloy will be thrust into the hottest part of the rocket's exhaust. Since extreme temperatures are a major problem in rocket construction, many alloys are being tested. Every action and reaction of the test material will be recorded. In this test, the alloy failed completely. It melted and caught fire. Here is an example of why scientific research is today a group project, employing many different technicians. These are high-altitude pressure cells necessary for many fundamental tests. They represent only one small segment of the missile agency's equipment. Yet to operate and maintain them is a big job all by itself. For the workers at ABMA, however, it is not all work and no play, since Huntsville is located in the center of Madison County, known as the playground of the South. The lakes and rivers of this area offer many delights. For the angler, there are bluegill, black bass and crappie, walleye, white lake bass, and many others. A veritable paradise for fishermen. Beauties, aren't they? Yes, not the least of Huntsville's attractions are its recreation areas, where almost every sportsman's wish can be fulfilled. If it's boating or water skiing you're after, nearby Gunterville Lake is 82 miles long. In the winter, this lake and the surrounding countryside teem with quail, duck, and doves for the hunter. And of course, no resort area is complete without its golf courses. The mild climate of Huntsville permits the golfer to pursue his hobby all year round. For ABMA workers and their families, this is pleasure-laden country. Yet they are here on serious business. Business like preparing for the static test of a missile. Held firmly in place, its rocket engines filled with fuel, a missile will now be studied during full-force firing. Enormous preparations are required for such a test. The control center, a blockhouse where the operating controls are located, is connected with a static test stand in the measuring room by underground wires. A few seconds before firing, the water is turned on. 4,000 gallons a minute are required to cool the flame deflector of the test stand.
6, 5, 4, 3, 2, 1, blast!
When the test is finished, the rocket is taken down and dried out. While the recording devices and observer teams have noted many of the test's results, a closer examination of the rocket must be made to determine how various parts withstood the static test firing. This missile will be disassembled and the detailed examination made back at the laboratory. Almost as many scientific skills are required to check out a missile's performance as were needed to build or launch it. If there is a single defective part within a missile, the best time to find it is before the test launching. By bringing to bear a great number of technical skills, it is now possible to achieve this ideal a large percent of the time. Fundamental to such tests is modern electronic and computing equipment and the knowledge of those who operate them. Here the contributions of many specialists and laboratories are gathered together in the final shape of the missile before it is fired. It is here that young engineers, under the guidance of men who have been in missile work since its beginning, come to know and work with all of the many systems involved in a missile, and apply their engineering and scientific training to devising and applying methods for ensuring missiles that will fire when they are needed and hit the target. In working with missiles under development, there is a constantly changing, ever new set of problems to match the continually advancing developments of the missile art. A whole science, telemetry, has been developed to transmit information from a free-flying missile to the ground. To record this information and analyze its meaning is a challenging task for the engineer. Information must be evaluated, not only for the missile, but for the measuring and telemetering equipment which records the missile's performance. In this broad field, scientists and engineers of all types find a common meeting ground through the use of applied mathematics and physics. All types of valves and mechanical components are put through their paces to determine if they are reliable for installation into a missile. Engineer detectives investigate causes of failures and recommend corrective action. As the missile grows larger and more complex, so does its testing equipment. This is the newest static test stand, a miracle of intricate design. It permits much greater flexibility in testing. Underground passageways with thousands of racks of wiring join it with a central blockhouse, where the control center and the measuring rooms have been coordinated in the same building. An extraordinarily complicated center, this blockhouse contains many levels of equipment. The location of each piece of equipment had to be painstakingly worked out in advance. A model of the blockhouse demonstrates the various breakaway sections used in the pre-planning of the center. Its fantastic electrical system, together with the innumerable pieces of electronic equipment, makes this a very valuable piece of property. Nothing was overlooked in the design of this multi-purpose center. When the results of the static test have been completely evaluated, the missile is reassembled. It is then heavily wrapped in preparation for transport to the firing range. A giant cargo plane carries the missile to its launching site. As a tactical weapon, one of the first requirements of the missile is that it be portable. At the firing range, the scientists will find palm trees and quiet sunshine. But their main interest now is to witness the culmination of their months of work. Before each firing, enormous preparations are made at the firing range itself. Men, tools, and equipment must be delivered to where the test will take place. A gigantic service tower, mounted on railroad wheels, will be used to service the missile in its upright firing position. When the missile is fired, it will be observed by television cameras and by a host of electronic tracking devices, which will record its performance. Tremendously high-speed X-ray cameras will even record the interior workings of the missile during flight. They must accurately record the results of many, many months of creative scientific research and development. The scientific and mechanical work being done on this project is both fascinating and unique. As the program continues to expand, it must have additional scientific personnel. Assembled together among the quiet hills of Alabama are physicists, chemists, metallurgists, mathematicians, and many different kinds of engineers. Electrical, aeronautical, mechanical, chemical, and countless others. Some of the most brilliant and imaginative men in the world are gathered here developing new weapons of defense that may someday play the major part in beating back a powerful aggressor. It is their job to keep the United States ahead of the rest of the world in the field of guided missiles. In the doing of it, new realms of knowledge are explored and the frontiers of science pushed constantly forward. That kind of work is rewarding in itself. Scientists at the Ballistic Missile Agency are additionally fortunate in the surroundings in which they work and live. Amidst unsurpassed recreational facilities and balmy year-round climate, they enjoy an amiable standard of living. Information about this program may be obtained from the personnel offices of the Army Ballistic Missile Agency in Huntsville, Alabama. For young scientists, here is an opportunity to learn and grow in an exciting new field.
And so, thousands of scientists and technicians are working together with the Army on the guided missile program. This data, knowledge, and production know-how, being acquired by the men at installations like Redstone Arsenal, will someday be turned to another purpose, when man's attention moves farther away from this small planet to the adventure of outer space. Now, this is Sergeant Stuart Queen, inviting you to be with us again next week for another look at your Army in action on The Big Picture.
The Big Picture is a weekly television report to the nation on the activities of the Army at home and overseas. Produced by the Army Pictorial Center, presented by the United States Army in cooperation with this station. You too can be an important part of the big picture. You can proudly serve with the best equipped, the best trained, the best fighting team in the world today, the United States Army.